Protecting trains from cyber attacks. Mr. Krishna Pandit will present it. He is product and solution security expert in Siemens.
Thank you very much for the introduction. Does this thing work? Perfect. Yes. So a little bit about myself. I'm since 2011 in Siemens now. I worked first in the Department for Train Control of High-Speed Trains, where I was doing the homologation aspects. Then now, for about a year now, I'm working in the group for cybersecurity for trains. And there I, on the one hand, manage all standardization activities, and on the other hand also am involved in customer projects where I accompany projects from the beginning to the end. Before that I was in the telecom industry in Qualcomm doing 3GPP LTE standardization. I have a PhD in computer networking, and besides my engineering career I'm also a philosopher and have a master's degree in philosophy. The outline of my talk, I will start with, I will give some motivation, but that will be very brief because we have heard so much motivation already today and yesterday. Then I will say something about standardization. I will show some train-specific challenges, and train-specific also means here first opposed to challenges outside the railway sector, but also challenges as opposed to challenges that we have in other parts of the railway sector, like signaling or fixed installations. Then I will give an example that is from our train IT system, and I will conclude with proposing a way forward for standardization. So, but as you can already guess here now, a lot of things, or maybe even all that I've said, we've heard already in the last 2 days. So just view this as a reshuffling of the information, and maybe if you reshuffle the information the way I do, we might see a new conclusion or a new way forward. So the motivation, I don't have to tell anyone that cybersecurity is gaining more and more attention in the media. And we've also heard the lawmakers have reacted. I mean, like Thomas Chatelet's talk yesterday pointed that out very nicely. This is both on national and international level. And but what all the legislation has in common is that the operators are always in the main responsibility. But of course, we as a manufacturer, we want to help the operator so that because security is always a team effort and we have to achieve it together. So now, this slide, actually you pretty much saw this slide in Francois' talk this morning. So all that I would like to say is that to meet legal requirements, we need standards. And then the IEC 62443 is the standard of choice that has been determined as the most suited, but it was originally designed for industrial plants. So what we need is an adaptation for the railway system. This part of the slide now, Francois already explained it. So the point is that there are all the stakeholders are there. There are operators, manufacturers, such as Siemens, and also vendors, which there are also a few in the room, and we all have to work together. But again, the 62443, we can't apply it the way it is there. We need this adaptation. And for this, we have the Senelec Working Group 26, which we also spoke about yesterday, and that will write a technical specification. I just want to put out the timeline here. So here we have the legal aspects of Germany. I mean, where we have in June the second basket of the so-called IT-Sicherheitsgesetz, or IT security law, became valid, and that says that within 2 years, so then we're like here, we need a that in 2019 the security law is going to will have to be implemented. Then on EU level, I mean, we have that in 2018 the national law has to be in effect, so Germany has already achieved this, not sure what the status is in other countries. And end of 2019 the operators have to be identified which qualify as critical infrastructure. And then how's the standardization going? We had the study group 24 where we heard the presentation yesterday. Here with the TC9X meeting where it was decided with the working group 26 on the way. Unfortunately, that is that's only going to start in November, and there's still the convener and has to still be decided. So, and then the target is to have a technical specification to submit it to Senelec first at end of 2018, but then Senelec will also take time to process it, and remember we have a deadline here, so time is really pressing here. And actually, I mean now as Francois presented earlier today, so in Shift to Rail there's already been a lot of very good work done, which can also be used for this technical specification. But what I would like to point out is that the Shift to Rail, this work that Francois presented, is focused on the signaling, because there are also signaling aspects. And here what I would like to highlight now is that we also have challenges which are specific to trains as opposed to like signaling, but also as opposed to other domains. And I will show 3, and Francois also had a slide showing all the specific challenges of the railway sector. They also all still apply. I mean, this is viewed as in addition. So the challenge that I will focus on now are what I label as physical access, diverse ecosystem, and mixed criticality. So first, physical access. As I said, 62443 was designed for industrial plants, and there you usually have a big fence around your plant, and then the physical access is not so easy for an attacker to overcome that fence. Whereas in our case, we have the passengers, which are of course right in our system, I mean, which is also the intended operational environment, right? And then we also have, like for service technicians, access on the roof and on the, and near the wheels, and that can also be used as attacking points for hackers. And then we have the train to land side. I mean, what I call the diverse ecosystem. So the train is only one part in a diverse ecosystem. That came out very nicely in Mike's ATO talk, that the train, you see, is only a small part in the whole ecosystem, where we have, like here, this is just an example, where we have like the ATO backend, or we have the even the customer, the operator side with his experts. We have the also, and then we have also here more like the data bases, and they're all over the place. So that is a shift from the paradigm where we just had one closed train that was going around. And of course, all this increases if we have like third-party cloud vendors also getting involved with operators. I mean, we already are seeing operators wanting to use like cloud services to store their data. And then last, the train-specific challenge is the mixed criticality. So we have non-safety critical systems on board, like the internet on board or the passenger information system. Already heard a lot about all of those, and they are mixed with safety critical systems like the train control or the train protection systems. And and these systems are inevitably interconnected because customers demand that from us. And what is also a challenge with regard to standardization is that not all systems on the train are developed according to EN 5126, so that is also a difference to the signaling world where pretty much EN 126 can be taken for granted. And so whatever we develop for methods for cybersecurity, this point has to be taken into account, otherwise everything will become unnecessarily expensive. I'll give now an example. So for our train IT, so the train IT is the Siemens platform for rail telematic systems for any kind of trains. And then we have applications like internet on board, passenger counting, and CCTV, but it is also the backbone and common services. It is implemented on many trains from Siemens, like Rhein-Ruhr Express, and S-Bahn Berlin, and Rheintal, and Rhein-Neckar. But we also offer it as a retrofit solutions for any kind of train. So if you want to buy one, we also have our salespeople here. And security has been part of the design, like right from the beginning, where we have a security gateway to separate the safety critical from the non-safety critical part. We have the separation of networks using VLAN and firewall. We have central authentication. We have a certificate management. I mean, actually, I think there was a discussion on that before. We have actually implemented it already on some projects. And we have cryptographically signed software updates, and also hardware protection, like private keys, and of course passwords with a password management system. And more in general, Siemens has the PSS initiative. So for many years already, we have been accompanying projects with our security management system. I mean, this is where the focus is on people, process, and technology. I'm not going to go through all the points now, but the key takeaway is this is an established process in Siemens. Of course, we always try to improve, but in the past few years, we have already implemented a good process here. And so now, all this in mind, let's get back to the standardization. So in SG24, a new work item proposal, I mean, it was written, but unfortunately it was not in a state to, it was not accepted yet, so it has to be refined in working group 26. That is a bit unfortunate that we didn't move ahead faster and get the new work item proposal already agreed. And then what is needed is a guidance on how to apply IC 62443 in the railway sector. That has to be the content of the specification. And then the train-specific challenges need to be addressed in the sense that we have to make sure that that all three parts of the railway sector, signaling, fixed installation, and trains are that can find themselves in one common in this one common specification. Otherwise, it will just get unnecessarily complicated. And we have we have agreement on a large part of the topics, and that moves to the next point. So what we need are commercially viable methods for operators, manufacturers, and vendors. I mean, it's a team effort. We all have to work together. And I would like to close with pointing out that the clock is ticking. The submission to Senelec is targeted for end of 2018. So let's get going. Thank you.
Thanks.